Hello guys, my name is Ian, and this week I'm back with another homework solution for Paul McWhorter's Arduino with Python series. This time it's lesson 12, and the homework was parameterizing some of the 3D graphics. Now what that's all about is having your LED, I think Paul's example was, and that's my example this week as well, but having your LED described in relative terms, so that if you want a bigger one or a smaller one, you don't have to go in and redesign the whole thing. You just change one thing and everything else follows through. So let's have a look at some of the code that I'm going to be playing with this week. We're talking about an LED. I actually have one in my code. I've had one for some time. We are looking at the code for it right now. This is a small LED, nothing special. Now we're talking about parameterizing it. As you can see, mine, this is the version 11 one, so that's last week's code, week before, something like that. It's partially parameterized, as in I can position it somewhere and I can change its color. So I've got some parameters. However, everything else in it is fixed, so its size is fixed. So these sorts of things here, the size of the base, the size of the body, the size of the dome, things like that, they're all fixed. So I can have an LED, I can have it of any color, and I can have it where I like. So why don't I show you that? So if I switch to this demo, you can see the LED. There's one LED. I've put axis on it to help us as well, but there you go. That's what it looks like. It's orientated in the Z axis, so that arrow pointing right out the screen is the Z axis, and the LED's basically pointing that way. Now, as I said, my code already allows me to basically have that any color I like and in any position I like. So if we quickly demonstrate that, I've set up what we're looking at here is not my code from last week, not all of it. I've got a special script just to play with this one class, this LED class. And if I change this to false, I can demonstrate how flexible my class is already. So if I kill off the single LED and run this, we shall see. Here she comes. Doop 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 doop. Talk amongst yourselves. Here we go. Right, so look, there you go. I've got lots of colors. I can put them pretty much anywhere I like in 3D space, but notice that they are all the same size and they are all pointing in the Z direction. My code is only partially parameterized, and the color and the position is the only things I can change. Everything else is fixed, hard coded in, can't do anything about that until I did something about that. So if we flick back to the code, I shall show you what I have done. So that's the original class, what we know and love. This is the new class, so it's going to draw me the same LED, but I'm bringing in an extra couple of parameters. One is the scale. So as I said, we want to draw things of a different size, so this is my scaling factor, and as we've seen, I can only point my LED in the Z axis, so I'm bringing in an axis parameter to tell me, well, maybe I want to point it in a different direction. So how does the code work? Well, first off, it works out what axis we're in to work out a scaling parameter for the different axes. And this is an important thing. If the x-axis is where we're interested in, and the scale is say 1 or 2 in the x-axis, the y and z axis are zeroed. We won't be playing with having multiples in more than one axis at a time. So I'm using an if else, which basically is a I'm looking, is it X? Is it Y? If it's neither X nor Y, then we're going to assume it's Z and act accordingly. Now I know Paul doesn't like the else, but I find it can give you more efficient code, assuming that you are aware of everything else that else could refer to. In my case, it's not X and Y, so I'm happy for else to be assumed as Z. Now, this is similar code as we've got before. I've introduced a bulb idea as Paul introduced last week. I thought that's a damned good idea, so I am happy to take it. What you'll also notice is I'm setting my parts to white, except this part here. Now, if we flick back to the previous one, you'll see they were all set to the off color, whatever the off color was, and the default was a grey LED, it's not lit. What I find is, because we're later on combining, using the compound model, which allows us for easier changing of the color all at once, the compound model coloring isn't as simple as you think. It just doesn't change the color of the parts, it actually blends the color. So if I want to change the color of the compound to be black, it blends black into all the other colors. Now, the base color is white, so basically white can be blended to any other color. On the other hand, the opposite of white is black. If I were to set these to black, no color would happen, no color change would happen. You can't blend black to anything else. So what have I done here? I've set them all to be white. That's basically a blank canvas for them to be blended to any color I want, or effectively they're not blended at all. The color I set them to is the color they will be put on top of white, except for the LED base. I've given it a very light grey. That has the helpful effect of making the base of the LED appear that little bit darker than the rest of it, which is the feature, the attribute I want, the effect I want. What I've also found is I'm working on a few other attributes to these objects. There's a thing called shininess, which I'm making the LED less shiny, as in reflective. And further down, whenever I'm turning it on and off with a different color, I'm playing with another attribute called emissive, which makes the LED look more like it's glowing from the inside as opposed to reflecting light that lands on it and bounces off it. So let's have a look at these. How am I changing it? Well, all these bits and bobs, they have a radius. Well, they had a radius in the last one. We look there, radius is set to 0.1. Well, in the new world, radius is set to the scale times 0.1, so effectively we're multiplying it up. And we do that for all attributes like radius. Was it any others that I do that to? There are. It's mostly radius, actually. Yeah. We'll get on to it. I use it in a different way in another part that I've done, which I'll show you in a little bit. Next we have these scales. Now they're the interesting bit. Basically what I do here is my model is going to, this piece of it is going to be a 0.2, set at 0.2 in the X, Y or Z axis, depending upon whether I'm playing in the X, Y or Z axis. Obviously if I'm playing in the Z, for example, those two parameters just disappear to be a 0. Now I've also made the LED a little bit bigger than the original, because it just looked more proportionately better. But if we look at this position and compare it to the previous one, you basically see there. So ignoring the 0.15, the original one in the Z-axis was hard-coded 0.15. Now if I'm playing in the Z-axis, I would be 0.2 in this case, but ignore that. But if I was playing in the X-axis, I would be 0.200. Therefore, that's how allowing me to play with this thing in different axes. That was all fairly simple for these objects, the dome, the bulb, and the body, and the base, because they're all round and they're centered and they're all balanced like that. The legs were a little bit more complex. basically because the legs of the LED, which if we shoot back to the LED, there it is. If we shoot back to the LED, what we see is, show you the legs. You see the legs are along one axis but off-centered from it, so they're not actually the same. They're either side of a center point. Okay, now that made it a little bit different, because that center point, when you have an LED on a different axis, is going to be a different center point. So what have I done to compensate for all that cleverness and awkwardness? Well, what you find here is the position is calculated. Now what you've got to think of is, this is working out a set of coordinates. So this is the X, Y and Z coordinate. Okay, now if we are playing in the X axis, the X scale will have a value of 1, say, and the others will have 0. Therefore all these parts will disappear, just leaving this part. So if I show you that as a drawing, I had to follow Paul's advice. I had to draw this out to get my thoughts straight. So here you have what I drew out. Basically I sketched out in this particular, let's take the Z one because we were familiar with that, and it looks the clearest in my camera. I've got the Z axis, I've got my legs, I've got the X axis, and I've worked out the values that the legs would be offset. So in the X axis we've got one leg is either side minus 0.05 or plus 0.05, and then the legs poke up a little bit above the X axis, well, into the Z, so they're 0.025 up. Now I've repeated that for X and Y, so this is when the X scale is something, this is when the Y scale is something, and this is when the Z scale is something. So that's basically when the LED is pointing in a different axis, and I've worked those out. Now if you take the X, the Y and the Z, that translates back into the code in the X, Y and Z. So whenever I have something in the X scale, those numbers that were in the the piece of paper, those numbers shine through. Similarly for Y and Z. So if we take this first one, for example, this is one leg, it's going to be X is 0.025, the Y coordinate will be 0.05, and the Z coordinate was 0. So that's these three here. When the X scale is something, the X, Y and Z pieces of this vector become as what the piece of paper says. So when X is something, we have our X, Y and Z pieces. The easy one to spot is Z is 0, and notice Z is 0 here. So that's how that's working. It takes some time to get your head around it, and it took me some time as well. So have a look at it, and then you'll notice this just adding on to the end. So after we've worked out our new stuff, we're adding on the vector, which moves it to anywhere we like. So excellent. We're using the compound, then we want to change it, we just change the compound's color, and that blends it in with the others. Really good. Now why don't we have a look and see what we get out of that. So if I change these parameters and tell it false for this one, because I want it to use my new LED, and then I run this code, so let's kill the old code, run the new code. So this is running the new class, and it's going to draw all the same LEDs in the same positions as we had them before, except we're taking advantage of the scaling and of the different orientations in the different axes. And this is what we get. So you notice that we've got, again, we've got colors, we've got space control, but we've got different sizes of LEDs. We've got small ones, medium, large ones, and we've got them in the X, Y, and Z direction. And here's an interesting thing as well, what I discovered. You can have positive scaling and negative scaling. And the difference between positive scaling, so like take this one here, that'll be a negative scaling, it points downwards, and a positive scaling points upwards, and you can do that in all the axes. So I can have them pointing up, down, left, right, in, out, any size, any position, and any color I choose. And that's all going there. And if you notice that those legs all look perfectly orientated around a center, no matter what direction the LED is pointing in. So there we go. That's it. Notice also the brightness of those. When those LEDs are on, that's the emissive parameter coming through. So that LED really does look like it is glowing, and the light's coming from inside it as opposed to reflecting off the surface of it. And the same goes to them all. And you notice these ones here, this one here, the off color doesn't have to be grey. The off color can be any other color you like. So there we go. Now let's show you another bit of code. Let's get you back so you can see it. This was just playing with an LED. There's another basic part I use in my model so far, and that's a screw. So let's draw some screws for you. These are the old screws. So we run that and we'll get you some old screws. So again, the old screw class, I'll show it to you, but I could have screws in any position, but always only in the Z direction and always the same size. And here they come. So there we go. There's some screws. Anywhere in any position. They've got a nice cross on the top, and I can have them in any space, like X, Y, and Z space. But they're all the same size, and they're all pointing in the Z axis, which is coming out of the screen towards me here. That's the top of the screws coming out of the screen. So let's have a look at the code for that. Similar sort of story. Here's the lesson 11 code. It just draws the pieces of the screw in a fixed size, and the only thing I can change on them is the position. So I haven't bothered changing the color even in the new bottle, which I'm just coming to. The interesting bit is the cross, the cross in the head. That took some thinking to get that right. So here's what the new screw function looks like. Yes, this is a function, not a class. Why is it a function, not a class? Well, I don't need to do anything. Once I've rammed a screw into the screen, don't need to change it, don't need to change anything about it. Therefore there's nothing for the class to benefit me with. Classes are good if you need to have an object and store information about it. Once I've banged in a screw, that's it, I've moved on. So anyway, here's this new function. Does similar stuff to the class. We work out the scale, is it X, or the scale is it in the X, Y, or Z direction. Then we start using the scale for the radius of various parts of the screw. There's the cone, the cylinder. That's one cylinder is the head, one cylinder is the shaft. I'll show you a zoomed in screw in a moment. And then we start playing with the crosshead. What we have to do here is work out its position and its size, right? Now the size is the bit, because effectively the parts of the cross are boxes, rectangles. So in different axes the rectangles are different sizes, because their height, width and depth changes according to whether it's the X, Y or Z. So a wee bit of fun working that out, but it's the same sort of idea. You've got a vector, and then this is the X part of the vector, this is the y part, and this is the z part, and then this is what you get in a column if we're scaling it and moving in the x axis, the y axis, or the z axis. And then of course the second part of the screw is same again, just 90 degrees shifted round, and that gives me the cross. Okay, so if I show you that now with my new function, and then we kill that old one, we fire off this one, and we jump over so you can see it as well, and here we go. Eventually yeah, it's thinking about it. Here it is. So there we go. We have screws of different sizes now in different directions, up and down. Again, that's the scaling. Negative or positive scaling gives you a screw going in one direction or the other. I can have them in X, Y and Z axis, up, down, in, out, left, right, and the cross is perfectly done in whatever axis we put it in. Now let's zoom into one of these screws and I'll show you those parts that I promised. There's one cylinder for the head, another cylinder for the shaft, and then we have a cone for effectively the thread, and then we have the couple of boxes on top which are sort of recessed into the head a little bit to give the impression of a cross in the head of the screw. So anyway, there we go. That's the code. I have started rattling some of these learnings into my main program for doing my whole meter. So this is the main program. I've put in the simple lead into it. I've put in my upgraded screw, but I've got a lot of work to do. I've got other meters to put the scaling through and all that stuff, and then the different axes. It's actually quite a lot of work, and you have to do a lot of thinking in 3D. Drawing it out really does help. Even if you can't draw, it helps you get your thoughts in line and helps you actually see things that you maybe didn't spot before, like, oh, this doesn't count in that axis, I can ignore it, it's 0. That's happened to me. Other thing to think about as well is what the axis is, especially when it comes to rotating. I got confused between pivoting and rotating. Okay, so that makes a big difference. Whenever I was working on my screw heads, I was, well, I'm turning in it, I was thinking, well, it's in the X and Y, but in actual fact, think about looking down on top of it, and I was twisting it. That made the difference. Took me overnight to think about that, but then whenever it came to me, it was a revelation. Made sense. I'd worked out what I needed to do, and now I understood why it worked. Anyway, as usual, all the code will be on GitHub. I've got the lesson 12 as far as I've got with it, and then I've got the A and B for the code for the LED model playing and the screw model playing. I will put all that code up on GitHub, usual place. There'll be links down below, etc, etc. Any questions? Drop me a comment. Have a great day.